All right, good evening. My name is Don Fick, and I'm with the Library Telescope Program, which is a program that is promoting telescopes for checkout in public libraries. And so we're here tonight to have our second video of the year, our 37th video overall. And what we're going to talk about is a program called Summer Reading Programs to support the Library Telescope Program. And we have Terry Menz from the Riverbend Astronomy Club. Now, before we get into that, what I'd like to do is just talk a little bit about the Library Telescope Checkout Program. It's really a great program. It's been around since 2008. There's over 1,000 library locations. We know of at least 6 countries that are participating in some way. You can see on this map of the world, really pretty much the US and Canada are very heavily involved in the program. We've got Europe on board and even New Zealand, some other places like that throughout the world. It's very simple. You go to a public library, check out a telescope just like a book. And there's also, with many libraries, we now have binoculars as well. Our task force we're all volunteers, and our goal is pretty simple. We want to grow the program and share best practices. We have an active Facebook page. Our Tom Lynch is on with us tonight. He runs our Facebook page. He's been working at this for quite a little while, and he's our rock star. He's got us above 6,000 followers. I think I have a 6,100, but I believe we're above 6,500 now or something like that. And if you visit our website, kind of cool thing we do, we get libraries that register with us, and we've got a world map. You can go in, for example, into Canada and pick up a province and just click on it and find out what libraries are participating. The same with the US and the same with other countries as well. And our Library Telescope website has also many resources for patrons and libraries. For example, if you go to our front page of our website, you'll find one of the it's a sky map. We have it both in Spanish and English, which is very cool. It's done by one of our members, which is with the Astronomical League. This is really a lot of fun. It's a very simple map, but it really helps you get started with the skies. It's free to download, free to use. And usually there's a couple other maps as well that are pretty cool. There may be some special event going on during the month that'll tell you about that and how to find that. So we have been doing this for a while, videos. We did several in 2023. We don't do them in November, December, but we started this year in January with one of our longtime members, John Goss, and he talked about 2024's most fascinating events as seen through the Library Telescope. It's a great video. If you go to the front page of the Library Telescope website, you'll find a really easy way to click and just watch those videos. Our programs are roughly 30 minutes, so it's not a very long watch. Tonight, we have a program called Summer Reading Program, which we'll get into in just a moment. And next month, we're going to talk about the eclipse coming up, and especially related to the Library Telescope. So we really hope you'll join us for those events. We will be taking questions at the end. We started a little late. I do apologize that. We will be taking questions at the end. We are live streaming on Facebook, and we also are in Zoom. So if you just drop it in the comments area in Facebook, and if you happen to be on Zoom, you could put it in the chat area, and we'll try to pick those up at the end. So with that, I'm going to stop sharing, and I'm going to turn over to our speaker tonight, Terry Menz from the Riverbend Astronomy Society, and she can go ahead and share her slide, and let's get started. Terry, we're looking forward to hearing about how libraries can use summer reading to promote the world of astronomy and have some fun with that. So I am seeing your notes page. Terry, I think you want us to probably see your whole slide page, right? There you go.
Yep. Is that better?
That's much better. Thank you very much.
Okay. All right. So as Don said, this is about summer reading programs to support the Library Telescope program. So what I focused on was thinking about what are your patrons going to see most likely in the skies around your library or even in their own backyards from using the Library Telescope. And so I wanted to make sure and focus mainly on that. So you'll see that in the outline that I have here. Okay, so I'm going to be talking about this, mainly about the solar system, the moon, and light and telescopes. So they'll see some solar system objects and the moon, and then kind of give them some background, kind of basic physics, so that they can kind of start to get their head around how telescopes work. And this is where it's great if you've got an astronomy club to help kind of bridge that, or perhaps later on we can go into it a little bit more about telescopes and how these concepts fit in. All right, so in solar system activities, there's 3 concepts that are very important for students or participants, all kids, to understand. And that would be, the different sizes of the planets and how they're really not the size they look like on the posters in their classroom. They're all very, very different sizes. And so they want to get a handle on that. The pocket solar system gives them an idea of how far apart they are. And then the third activity is where are the planets? And that activity uses the computers. So if you're computerized, and there's other ways to work around it, that will help them understand why we don't see all of the planets every month or every night, and how that can change from one time to the next. So on this, one of the things I want to mention before we get too far is all of these activities have links in the back, and I've sourced them in different places, and they are available through the Night Sky Network for the most part. At the very back of the slide presentation, I have slides for each of the 3 categories and the links that'll take you to the activities. So this first one, this is a scale model of the solar system. They provided this from the Night Sky Network to our club. I don't believe that they're making this kit anymore, but the directions for how to build it yourself are included in that link. And the little tabs that are on each one is printable and so on. So all of this material is available, but it shows just the vast difference between the sizes when we go from Mercury to Earth to Jupiter and then back out to Pluto. And then just to help them, a take home that they can have with them is the solar system to scale. And it helps a bit, although this is still not quite the scale, as you can tell by the picture, but it does help a bit. So this has some other details about each of the planets as well, but I believe this one was developed after Pluto because Pluto thing is not on here. Okay, so the next concept then is the pocket solar system. I've gone over this in another video before, another Zoom talk before, but what is neat about this one is it's so simple. The instructions, and there's, I believe, a video available to show you how to do this particular activity, but on this, what you're using in this example is a adding machine tape, and you're making a series of folds. And they're not in order by the planets. It's in order just by folding by half, by half, by half, until you get down to the very end of the solar system near the sun. And you have so many planets in that one small part that is near the sun that it really drives home how far away the gas giants and the ice planets are, and how far Pluto is, and why some of that makes a difference. The size as well as that distance makes a difference in why it's hard to see them. Sorry about that. All right. Now, the third dimension is going into where they are around the sun. Now, this brings us to a website. It's from Formulab, and it's kind of like there's a device called an orrery that you may have remember from your high school physics class, or you're in your science room, but it helps imitate, and there's a picture of it there on this website, but it shows how the planets rotate around the sun and how the orbits are so vastly different, and how the planets are so end up being different places around the sun. On this web page, the first link you want to click is this one marked with the arrow, entire solar system. So we're going to get started with that page, and it's going to show you this menu. Now, this menu needs to be modified in certain ways. You look at the purple arrow, it's pointing to the date, and it's put in a very specific order, and then the time. The time in this case is not as important as the date. So putting in the date that you want. So if you're going to do this on June 15th, if you're going to do your week on June 15th, you pull up that date and you put that in the box, and then it'll show you where the planets are on that particular date. You also want to make sure that you're seeing the full system. So the beige arrow points to the full system, and there's a little blue toggle there, and it gives you the whole system and all of the planets. Now, looking at this diagram, you wonder, well, I can kind of figure out what all these are, but what are all those symbols if you're not familiar with them? And that's kind of confusing to kids. So if you were showing them this picture, or they were doing it on the computer, then there'd be some things to change. And this can be projected. I've done that in the past too, where you project it on the wall, and you have once you've set all the settings, then you have the students look at that, or the youth look at that. Okay, so let's say we want to change those symbols. So we go to this kind of a pinkish, purplish, more red, I guess, but that arrow that's next to where it says images or icons. So you want to click the toggle that says images. Now, when you do that, and then go back to the update button, that's when it's going to update everything that you've changed on this screen. So update is by the green arrow. Okay, so once you've got it all set and you press update, you're going to get this image in that box at the top. And this is going to be much easier to decipher, although it gets kind of crowded down here in the center. So now we can tell where's Pluto, where's all the different planets in order as you're going in to the sun, which is in the center. So they can at least get some of the outer planets and decipher where they are. And then we go back to that main menu, and we then select inner solar system. And now we can discern where all of these others are. Now, what is the purpose of doing all that besides just observing it? Well, what we want to do then is we have a link also to this diagram, which is called Exploring Our Solar System. And it is a place to make dots, basically, that show where those planets are, in what position around the sun. Now, interestingly enough, if you look in the center, that blue circle is actually the Earth. So we're going to put the Earth in whichever portion of this blue circle corresponds to the month. So it's hard to see from here, but each month is designated with just a little hash mark, so you go in between the hash marks, and it's, April, May, June, whatever. And you can put your Earth there, and then using the outer solar system, you can get Saturn and Jupiter, and then come in and do some of the inner ones. But in order to plot the very outermost planets that don't fit on this page with this scale that we've got, then you go up to the corner, there's a Milky Way galaxy total, and then there's a smaller diagram of just the outer solar system, and that's where you plot, Pluto and Uranus and so on, and you put those up in there and make dots up there. So that kind of gives them an idea how big it is, how much distance there is from the sun out to the outer planets. They don't even fit on this page. This shows the zodiac, which is also kind of an interesting correlation with, where the Earth is and what constellation is up in which month. And it also kind of helps understand the guide that astronomers use as to how to find those planets, because since they're changing all the time as to where they are relative to the Earth, then you can kind of place them in the sky. It's a good locator. One of our other library telescope task force members, Geraldine Ramirez, who's in the Kansas Astronomical Observers, she created these stickers, and they're really a great idea. And the link to go print those is in the references. But one thing to keep in mind is, as we said, there's such a distance between some of the outer planets, specifically Pluto and Neptune and Uranus, that sometimes it's really, really hard to see those. And it's, I don't know if anybody's ever found those outer ones with a library telescope, but I have found that the ones that are seen most often when we're doing observing, with the library telescope is Venus and Mars, Jupiter, and Saturn. So if you were going to print some of these, if you're going to have an event, and you had to, borrow the telescope and come back to the library and, say what they found, you can get your best bet is to just print those 4, because that's most likely the ones that they would see. Okay, so that's it for the planets. Now let's go on to the moon activities. Now, some of these are very, very simple, but they still are a great teaching tool. So the moon craters is the first one. Then and it kind of talks about how they're made and some of the features. The moon phases, that's a real fun one. You'll see why they're so popular, but still teaches a good concepts. The moon rover is one that I have to be honest, I haven't tried, but boy, I would love to do that. But it'd be just a fun thing to structure a week around just the moon and include that in there. And then an activity that I found, crash landing game, that I just sometimes just carry it along with me if I'm thinking there might be some lag time between activities or telescope viewing for groups of scouts. And it's a great team activity. So we'll get to that too. Now, this particular activity, it uses very simple. It uses aluminum pie pans. You fill them with flour. You sprinkle them with hot chocolate or grape Kool-Aid. And then you have just some rocks, and you have the participants just drop their rock. It's kind of like the game where you put the clothespin in the jar or in the bottle, but you just stand right over it, and they drop the rocks into the pie pan of flour, and then they'll see how it kind of blows the flour out, and it projects all of the upper crust, which is the Kool-Aid or the chocolate, out, and then the pattern is made with the white flower underneath that mimics the ejecta rays that you see on the moon. Excuse me. So you can talk about, that's what causes those rays coming off of that crater. You can also see on the moon craters that have a little peak in the middle, and that's when whatever hit the moon at that spot, or whatever hit the pie plate, and it's harder to get in on the pie plate, but whatever hit that spot bounced out so quickly that it kind of pulled up a little, had a little suction in the middle and pulled that up. And sometimes those are caused by volcanoes as well, but you could sometimes simulate that with this activity. So that's kind of interesting. All right, moon phase is the one that's really popular. It's because it uses Oreos. So if you pull apart an Oreo just perfectly, you get a new moon and you get a full moon. And then you also can give the kids like a plastic knife, and you say, okay, now we got to make all the other phases. So let's move some icing around and see if you can make your Oreo, one half of your Oreo look like each of these phases. So you give them about, 4 to 8 cookies and let them go through and do each of those phases. Now, it's really nice if you can go ahead and have the paper plate, and if they're able to write those or copy those phases down, then get them put in the right order, the way they appear throughout the month. And that kind of drives that point home of what's what phases do they go through and what names do they have, or how do we refer to them? So they love that one. And that's a good one if you want to give them a take-home activity to do. All right, finally, here's a build a moon rover. And I think this would be a really cool one, because once you've studied the moon craters and you say, well, how would you get across the moon with all those big craters in the way? And then you could kind of go through that thought process with them and let them design their own. So I have like a make it day, and they can create these. So I've got instructions on both of those, or 2 different links to get to the diagrams and the instructions for this. And then finally, Crash Landing Game is it's a part of Project Astro from NASA. And it's basically these astronauts have crash landed on the moon, but there's still a distance away from their home base. So this is futuristic, when we have actually a moon base that they're trying to get to. And they have to decide of all the things that are in the wreckage, and they're given a list of those things, what objects are best to take with them as they hike across the moon to get to their base, and which items are best left behind. So you divide kids into groups and let them talk about it, use the team approach, debate it, give their reasons why this is good to carry or not. And then they, once everybody's come to their decision, you have them share what did they decide to keep or not, or what to take and what to leave. And then you can then go over what an astronaut or someone who works at NASA would think was the best things to take and leave, and why. And so that is a kind of revealing to them, especially if they haven't figured out that a compass is worthless on the moon. They might not know that. So that is a really good one. Now, telescope activities. I've included some background slides. Just, they might be a good handout or a good just a slide to show to the kids and kind of go over them. You can put them by the appropriate activities if there is an activity that's best for that one. I don't have it for all of them, but some of them I do. Okay, the first one is telescope. Telescope collects and concentrates light. So this is a description of how that happens. And if you have a bigger telescope with a bigger opening or aperture, what you have at the top that's collecting the light, that's going to help enhance that image and make it a little clearer. And then we have reflection, and that's easiest for them to understand, but it talks about the definition of it and in terms of rays, which helps too to lead into some of the other concepts. And then refraction, that's a good one because they identify with the rainbow and identify with the fact that it just rained, so there's water in the atmosphere. And then you kind of go a step further and then explain it further with how the light rays going through a different medium is going to change the way it behaves, the way that light ray behaves. So that's the other part of that reflection concept. Now it's a time to demonstrate it. So now we have a refraction demonstration. It's just real simple. And so once they've learned about diffraction, now look at this image and then try to explain why it's happening. Okay, this goes back to refraction and reflection. And it's saying refraction, what is refraction and how refracted light forms that focal point. And then reflection and how a curved mirror will behave in a way like a curved lens and make those images bounce just so or bend just so that they come to a certain point. And then you can talk a little bit more specifically about that focal point and how it appears to turn the image upside down and why. And this is a great example from Night Sky Network where you could take a curved, shiny, I like to get a really shiny curved spoon and have them look at it and see how they look upside down. You can do this with a Dobsonian mirror, and that's a real popular one. And I believe we can do that with a library telescope mirror, if I'm not mistaken. Then we get to another demonstration that kind of helps enhance that explanation. You take a piece of foam and it has barbecue skewers. You cut off the sharp end and you insert them evenly throughout that foam. Then put a little dab of glue, like Elmer's glue or something, and to keep them seated in that foam. And then show how when you just look at yourself in a flat mirror, the light rays are going from the top. If the light rays that bounce off the top from your forehead, then from the mirror and back, it's to your eyes, it still keeps your forehead on the top and your chin on the bottom. But when you bend the sticks, like it's creating focal point, and then follow a single stick, you see that what was at your forehead is now down by your chin, and so on. And so it gets down the explanation down a little bit better. Okay, and then the last part of the telescopes is how we use colors, light, and filters. It leads into this by just looking at a color wheel and then talking about the spectrum of visible light. There's a jumbled up bunch of letters, And the whole key to all of these cards, there's instructions on the back too, but is to use a filter, either a red, a blue, or I believe it's a green filter. And those three filters, you have them use those on each of the cards, the different colors, and see what changes and what looks different. And there's a secret message in the letters. And using the different colors, you kind of can see how the Crab Nebula, its appearance changes slightly depending on what filter you're using, and kind of transition to that, how that's what NASA does. They use filters to get different information when they look in a telescope at different objects, or when they look at images of different objects. And then again, this one, the one has like sea creatures, and depending on what filter you have, it peek out. And then there is an aspect to the one with the flowers having to do with UV light. The only problem is it's not necessarily easy to get on a UV pen. There is one, but available, but it's you have to go out and locate it online. Oh, and the link to, well, let me show you the filters. So this filter came with kit we got, but I had located online a set of gel films, like cellophane, that you can order, and it's reasonable price. And then you can cut up a bunch of little squares, and then each student can have their own filters as they pass the cards around. One of the best extensions of this is to take highlighters in those same colors, a green and a blue, and then kind of like it's kind of a pink color, but it works for the red because we don't usually use red highlighters. But if you give them just some blank paper and let them go at it, they can either write their own secret message, or they can draw a picture. And maybe the head is one color, the body's another, and the legs are the third color. And they use, depending on the filter, each, part of the animal or the figure will disappear. And it's just kind of a fun thing for them to first figure out, how can I write this secret message and put the right letters, scatter them throughout, and still have them come up with the message. Like this one is, now you see the light. So that's a kind of a fun activity. I had some kids recently do that one, and I swear it was the hit of the whole evening, was doing just those secret messages and laughing about them. There is a way to do this online, or not online, on your phone, and that website right there is how you would get to it. And there, I believe one of those cards has this QR code, and it will help them get to this website as well on their phone. And this is the National Radio Astronomy Observatory that created this. And you can click this toggle for radio, infrared, visible, ultraviolet, or X-ray. Now that goes beyond what the kids might understand, but the rainbow that we see extends both directions into the ultraviolet and X-ray, and on the other side to the infrared and the radio waves. And that this kind of drives that piece home. So it's a bridge over to how they truly use these in astronomy. Okay. Again, I told you that I promised you that I'd have the links. And so those are the last 3 slides of this presentation. And that was just one of them. Let me get back to PowerPoint. Can you guys see the moon activities descriptions now?
I see a title and a link. That's what I see.
okay, I've got several links on this page, but the last 3 pages are going to have that, have those links. So when the video video comes out on YouTube, you'll have those links available too.
Okay, yeah, we'll get the links out there. So that was great. What I really liked about it was it's not complicated stuff. Once a person like a teacher that's not even an astronomer understands kind of what happened, there's a lot of fun to be had with this. It's very hands-on and activity-based. It's not just talking and presenting. It's something where they can actually do stuff and visually connect what's really going on. That's really fun, right?
Mhm.
So, do we have any questions from the group here at all? Again, our goal is to tell libraries some things to do during the summer, and talk about optics and astronomy and light and things like that.
Mhm.
Let's see some hand waving there.
Great presentation, Terry.
Oh, well, thank you so much. I appreciate it.
Yeah.
If you have any
That's Mary
questions.
Mary and Robert from Delaware.
Thank you.
Well, that's great. Terry, this is good stuff. I'm going to make sure now this will get linked on the front page of librarytelescope.org, and it'll be in our YouTube, and it'll also be on Facebook here. So are there any questions from the Facebook crowd here? So if anybody has any questions, just let us know and we'll try to answer those. This is good stuff. Boy, I think I love this. I'm always looking for hands-on stuff. It's, when you work with youngsters, they just need to be stimulated, and, talking's not going to do it. You got to give them really something to do with their hands. And what's really good is you got such a variety of things here, between light and optics, and it's not even expensive stuff to do this, right? I mean, this is
No.
all really very
No.
inexpensive. Yeah.
It's not. And especially since that, as I said, some of those links, you can just print those out. Now, those cards for the light activities, those would be good to print on cardstock, two-sided and of course in color, but just for longevity. But you could do them, and laminate them. That would work too. Just do them.
Right. All right, do we have any questions from the group here? All right, well, cool. All right, well, Terry, that was really awesome, and thanks a lot for, I know you've got some experience. I know I've talked with you for a while. It's not like this is your first rodeo. You've been doing this, and I've watched you in action, and the children respond to what you're doing. And so thanks so much for sharing what your big ideas are, and I know that people will be happy to use those. So, all right.
Well, thank you so much.
Yeah, and thanks to everybody for the help tonight. Thanks, guys. Have a good evening.
You too. Bye-bye.